Hi guys, here's the review video going over your fall final exam review. So for problems 1 and 2, you're trying to find the domain of each function. Basically, the only time you have issues with domain is if you have a radical or you have a rational expression. So if I look at number 1 is both a radical and a rational expression because I have a radical in a fraction. So with radicals, everything that is underneath the radical has to be greater than or equal to 0. However, with this particular scenario, since my radical is in the denominator and you can never divide by 0, it just has to be greater than 0. Okay, it cannot equal 0. So I'm going to continue to solve this inequality. I'm going to add 3 to both sides and I get x is greater than 3. And there's my domain for the first one. So you might have your domain written as an inequality, or it could be an interval, an interval notation that is going from 3, and it's greater than 3, so that's going from 3 to positive infinity. So you might have your answers written in either of these ways. For number 2, that denominator cannot equal 0. So x squared plus x minus 6 cannot equal 0. So I'm going to factor this. That factors to x plus 3, x minus 2, and that cannot equal 0. So that means x cannot be negative 3, and x cannot be positive 2. So for your domain is all real numbers, except with x not be negative 3 or 2. Writing that in interval notation is a little complicated, but it can be done. That's going from negative infinity to negative 3, negative 3 to 2, and 2 to infinity. So it's basically the entire interval, except with the negative 3 and positive 2, you put parentheses around it and you break it apart. So there is your interval for number 2. Number 3 is asking, determine the intervals that the function is increasing, decreasing, or constant. So I'm going to go from left to right on my graph. So left to right, going from negative 5 up to this point right here, it's constant, so it's flat. So my interval for constant goes from negative infinity up to negative 1. Because this graph right here keeps going to the left. So negative infinity up to negative 1. And then as I continue, going from here, my graph is going down, and then at this point it turns and starts to go back up. So when it's going down, that's decreasing. So my interval for decreasing is going from negative 1 to 0. And my interval for increasing goes from 0 to infinity. Now, anytime you're writing intervals for increasing, decreasing, or constant, you're always using these x values for your intervals. So for example, for this part, which I'm going to highlight in green, your x is going from 0 all the way to infinity because it's going to keep going right. All right, for 5 and 6, actually that should say for 4 and 5, describe how the graph of the function compares to the graph of y equals f of x. Use language of transformations. So the number inside the function is going to tell us if we're moving to the left or to the right. Since I am adding 3, I have a horizontal translation. Of 3 units to the left. And then the minus 6 on the outside is a vertical translation of 6 units down. For number 5, I have this 3 in the front. The 3 in the front is going to create a vertical stretch. By a factor of 3. The -4 on the inside is a horizontal translation. To the right 4. And the +3 on the outside is going to be a vertical translation up 4. And those are your transformations for 4 and 5. 6 and 7 are very similar to each other, so I'm only going to do one of them. I'm going to go ahead and do number 7 because of that radical. So there's 2 parts to this problem. It says find f plus g of 3, which I'm going to go ahead and do first. So to find f plus g of 3, I'm going to go ahead and do f of 3 plus g of 3. And f of 3 means I'm going to take 3 and plug it in for x into my f function. So the square root of 3 plus 6 plus g of 3, I'm going to take 3 and plug it into my g function, so negative 3 squared plus 2. So that gives me the square root of 9 plus negative 3 squared is 9 plus 2. So that's 3 minus 9 plus 2, which is -4. And then for the other piece, that's doing f minus g of -2. But again, you're doing the same thing. That's f of -2 minus g of -2. So f of -2 is the square root of -2 plus 6 minus g of -2 is -2 squared plus 2. Now, since I am subtracting, I'm going to put that second quantity in parentheses before I actually subtract it. So this gives me the square root of 4 minus, let's see, that is -4 plus 2. So square root of 4 is 2 minus -2, which is +4. So your answer for that is +4. All right, let's keep going. For 8 and 9, you are finding the composition. So I'm going to go ahead and do number 9 since it's the more complicated out of the 2. So I want to do g of f of x. Another way to write that is like this, g of f of x. So that means I'm taking my f function and I'm going to plug it into my g function. So it looks like this, g of x plus 5. So this x plus 5 is going to go in for this x into my g function. So I have x plus 5 squared plus 8. Now x plus 5 squared, you have to actually multiply it out. It's x plus 5 times another x plus 5. Or I always like to do the square double square trick. I'm going to square my first term. I'm going to multiply these two and double it. So x times 5 is 5x. Double it gives me 10x. And I am going to square this term. So 5 squared is 25. And then finally plus 8. So I have x squared plus 10x and 25 plus 8 is 33. So there is your answer for number 9. For 10 and 11, you're finding all of the zeros of the function and stating the multiplicity of each zero. So for this one, I'm going to make a note that you are going to factor. So again, since both of these problems are very similar, I'm going to go ahead and do number 11. So if I look at all 4 of these, or all 3 of these terms, I'm going to look for the greatest common factor, and the greatest common factor is a 4 and an x squared. So I can go ahead and rewrite this as f of x equals 4x squared. And when I factor out the 4x squared, that leaves me with x squared minus 2x. And 140 divided by 4 is -35. I'm going to keep factoring. So that's 4x squared, 2 numbers that multiply to -35. and add to negative 2 are negative 7 and positive 5. So I have a 0 from here, and from here. So let's go ahead and find all of those zeros. So I have 4x squared equals 0, divide by 4, x squared equals 0, square root. So you get x equals 0. For this one I have x minus 7 equals 0, so x equals 7. X plus 5 equals 0, so x equals negative 5. Now it does say to state the multiplicity of each 0, so I'm going to go ahead and list them all out. So for my first 0 of 0, that actually has a multiplicity of 2, and the reason why that is because it came from a squared factor. So that x is being squared, which means it is used twice, so your 0 is going to have a multiplicity of 2. My 7 has a multiplicity of 1, and my negative 5 also has a multiplicity of 1. Only because these two factors were used once. Now let's say this x plus 5 had a cubed on the outside. That means that factor is used 3 times, so it would have a multiplicity of 3. But here is your answer for number 11. 12 and 13, find a polynomial f of x with a leading coefficient of 1 having the given degree and zeros. Again, I'm just going to do one of them because, the process is the same for both of them. So when I tell you the degree for both of these is a 3, which means in the end you should end up with an x cubed. So if I look at 13, I have 2 zeros. I have one at 1 and one at negative 2i. But I'm supposed to end up with an x cubed, which means I should have 3 zeros. Well, my third 0 comes from the fact that this negative 2i has a pair, has a conjugate pair. So my other 0 for negative 2i is going to be a positive 2i. So your imaginary zeros always come in pairs, so we'll have to make a note of that and make sure we put that second 0 with the other zeros. Now to actually write out the polynomial, we're going to set up our factors. So if I have a 0 at 1, my factor is going to be x minus whatever that 0 is. So x minus 1, x minus negative 2, which becomes x plus 2i, and x minus positive 2i, or x minus 2i. I'm going to go ahead and multiply these two first. That way I can get rid of my i's. So x times x is x squared. X times negative 2i is negative 2ix. 2ix is 2ix minus 4i squared. My ix's cancel, so I have x squared minus 4i squared, but I squared is negative 1. So that becomes x squared plus 4. And I still need to multiply that by x minus 1 in the front. So x times x squared is x cubed. Negative 1 times x squared is negative 1x squared. X times 4 is 4x. And which one did I miss? Oh, I did the x times 4 twice. Whoops, 4x. And then negative 1 times x is, or negative 1 times 4 is negative 4. So there is your polynomial. And if I look at my final answer, I have a degree of 3 because I have an x cubed. All right, synthetic division. So I'm going to do 15. So anytime I'm setting up synthetic division, I'm going to go ahead and set up this box. I'm going to take the opposite of this number, and that's what's going to go in my box. And then from there, I'm going to list out my coefficients. So I have negative 2x to the 4th. And if you notice, you're missing an x cubed, so I'm going to put in a 0, x cubed. I'm also missing an x squared, so 0x squared, 10x minus 3. Don't forget to put your zeros in there as placeholders anytime you're missing a value. Now to run through the synthetic division, your first term goes straight down, so negative 2. Negative 2 times 3 gives us negative 6. Combine. Negative 6 times 3 is negative 18. Combine. Negative 18 times 3 is negative 54. Combine, so that gives me negative 44. Negative 44 times 3 is negative 132. Combine, so I have negative 135. So whatever ends up in this box right here is your remainder, so that's going to be my remainder. To write my final answer, since I started with an x to the fourth in my original problem, my answer is going to start with 1 degree lower, so x cubed. So I have negative 2x cubed minus 6x squared minus 18x minus 44 plus negative 135 over what I divided by, which was x minus 3. Now you're more than welcome to write this as just minus instead of the plus negative. It means the same thing. And there's our answer for the synthetic division. 16 and 17, you can go ahead and put these in the calculator if you want to, so I'll make a note, these are calculator problems. Just double check your mode. So if you take your calculator, click on mode, and just double check that a plus bi is highlighted. Otherwise, when you do try to put these in the calculator, you're going to get some errors. So I'm going to go down and highlight a plus bi, and then I'm going to type this in exactly how it looks. So 3 minus 2i, I is right above the decimal, times 2 plus 4i, and the calculator gives me 14 plus 8i. And then for the next one, again, I'm just going to type it in. So 6 minus 3i times 6 plus 3i is 45. Now you're more than welcome to multiply these out by hand if you want to. You would still get those same exact answers. If you're going to multiply it by hand, you're just using FOIL or distribution. For number 18, we want to write the quotient in standard form. So what we need to do is we need to rationalize that denominator. So we're going to multiply by the conjugate of the denominator. So my denominator is 2 minus 3i, so its conjugate is going to be 2 plus 3i. So your job at this point is to multiply all of this out. But again, you're more than welcome to use a calculator if you want to. So the first thing that I'm going to plug into my calculator is this product. So 4 plus I times 2 plus 3i, and that gives me 5 plus 14i. And then my denominator, I'm going to go ahead and multiply those two. 2 minus 3i times 2 plus 3i, and that gives me 13. So this is over 13. Now when it does say to write it in standard form is a plus bi form. So that means I just need to separate this. So I have my a plus bi, so that'd be 5/13 plus 14/13 I, and that is in standard form. For 19 and 20, it says find all the zeros of the function. Instead of showing you how to do this by hand, I would highly recommend that you do this on the calculator, because there is a program on the calculator that will solve these for you. And the program on the calculator is called Polysym. So I'm going to make a note, Polysym on the calc. So on my calculator, I'm going to go to Apps. And I'm going to scroll all the way down until you see something that says PLYSMLT2. And then I'm going to hit enter. It's Polysimulator 2. And once you hit enter, it says Polynomial Root Finder and Simultaneous Equation Solver. Press any key, so I'm going to press any key. So what I'm looking for is I'm looking for the root finder. So that's the first option, it's number 1, so I'm going to hit enter. And if I look at this, it's going to ask for an order. Your order is your degree. So if I look at number 19, my degree is 3, so I'm going to make my order of 3. I'm going to make sure that a plus bi is highlighted. And then from there, I usually put it as fractions. That's one of your options on the calculator. Everything else doesn't really matter. And then I'm going to hit next, which is right above graph. And then I'm going to start to type in my coefficients. So I have 1x cubed, negative 6x squared, 13x, and negative 10. And then I'm going to hit solve. I wish I could show you what it looks like on the calculator, but just kind of go with how I'm describing it. And it gives me my 3 zeros once I hit calculate. Was it calculate? Oh, shoot. I lost it. Oh, it was solve. Once I hit solve, it gives you the 3 zeros. So I have a 0 at 2 plus 1i, 2 minus 1i, and 2. I'm going to go ahead and do the same thing for number 20. Use polysym on the calculator. Might as well, since you just have one shot on the final exam. So I have 1x cubed, negative 7x squared, 4x, and 102. I'm going to hit solve, and my zeros are 5 plus 3i, 5 minus 3i, and negative 3. And there you go. Easy peasy when you use the calculator. Okay, vertical and horizontal asymptotes. So for vertical and horizontal asymptotes, I'm going to go ahead and start by factoring my denominator. So for 21, I'm going to factor my denominator. That leaves me with x over x plus 4 and x minus 4. Now for your vertical asymptotes come from any of the zeros of the denominator, since you can't divide by 0. So I have a 0 at negative 4 for this first one, positive 4 for the second one. So I'm going to have two vertical asymptotes, one at x equals negative 4, and the other at x equals positive 4. For horizontal asymptotes, you need to compare the degrees. So you're going to compare the degree of the numerator versus the degree of the denominator. So the degree of the numerator is 1. Degree of the denominator is 2. So since my degree of the numerator is less than the degree of the denominator, that is going to make my horizontal asymptote y equals 0. Mr. Ramsar just interrupted my video.
Sorry guys, didn't know you were working. She was working so hard on this stuff. Good luck on your finals. Study hard.
All right, got distracted by Mr. Ramsar. So 22, again, I am going to factor it. So my numerator is still 3x squared. My denominator is, let's see, x minus 4, x minus 3. And my vertical asymptotes come from the zeros of the denominator. So I have one at x equals 4 and one at x equals 3. Now for my horizontal asymptotes, I'm going to look at the degrees. Degree of the numerator is 2. Degree of the denominator is also 2. So that is when your horizontal asymptote, since my degree of the numerator equals the degree of the denominator, can't spell denominator, then that is going to be the equation y equals a over b, where a is the leading coefficient of the numerator, which is 3, and b is the leading coefficient of the denominator, which is 1. So it's just y equals 3. So that is vertical asymptotes and horizontal asymptotes. 23 and 24, solve the inequality, graph the solution on a number line. So I'm going to start by getting this with a 0 on one side. So I'm going to subtract 81 from both sides. So I have x squared minus 81 is greater than or equal to 0. I'm going to go ahead and factor it. So that's x plus 9, x minus 9 is greater than 0. And what I'm looking for right now is I'm looking for critical values, or my critters. So my first critter is negative 9, and my second critter is positive 9. It's the zeros of your factors. So on my number line, I'm going to go from negative 9 to 9. And since my inequality has to be greater than 0, it cannot equal 0. That means at -9 and at +9, I'm going to go ahead and put parentheses instead of brackets. So my first interval goes from -infinity to -9. Second interval goes from -9 to +9. And my third interval goes from 9 to infinity. And what I'm looking for is I'm looking for test points within each of those intervals. So from -9 to -infinity, let's say our test point is -10. I'm going to take -10 and plug it into here. You can plug it into here if you want to. It doesn't really matter. But I like to plug it into the factored one. So if I take -10 and plug it in, that gives me a number that is positive. Now I don't really care about what the number is, so I'm not even going to tell you what it is when I plug in -10. I'm just going to say that it's a positive number. All I care about is whether it's positive or negative. A number from -9 to 9, I'm going to go with 0. I'm going to plug in 0, and again, I want to see if that number is positive or negative. And that number ends up being negative. And then 9 to infinity, let's go with +10. I'm going to take that, plug it in, so that gives me a positive number. Now your final answer goes back to looking at this inequality. So my inequality says that it has to be greater than 0. Well, what does it mean to be greater than 0? Well, greater than 0 means that it is positive. So I have two intervals that ended up being positive. That was this one, going from -infinity to -9, as well as this one, going from 9 to infinity. So my final answer is the graph, as well as writing my intervals. So -infinity to -9 and 9 to infinity. I'm going to do the same thing with 24. So I'm going to get a 0 on one side, so x squared plus 2x minus 8 is less than or equal to 0. Factor it. So x plus 4, x minus 2 is greater than or equal to 0. Find your critters. So I have a critical value at -4 and another critical value at 2. So I'm going to set up my number line again. And I have my critter at -4 and my critter at 2. Now this says that it can equal 0, so at each one of those critical values, I'm going to go ahead and put a bracket instead of a parenthesis. And here are my intervals: -infinity to -4, -4 to 2, and 2 to infinity. And again, I'm going to pick test points and determine whether they are positive or negative. So I'm going to plug in -5 for my first interval, and that results in something that is positive. I'm going to plug in 0, and for my second interval, since 0 is in between -4 and 2, that results in a number that is negative. And 2 to infinity, I'm going to plug in 3, and that results in a number that is positive. And if I look back at this inequality, I need it to be less than or equal to 0. Well, less than or equal to 0 means that it is negative, so that is this interval right here. So my final answer is that graph, as well as the interval -4 to 2. All right, 25, I'm going to start by breaking down 729 in terms of 3. So I'm trying to figure out 3 to what power gives me 729, and that is 3 to the 6th power. Since both of these have a base of 3, I can go ahead and drop the bases and just focus on the exponents. So now I have 5x minus 12 equals 6, and I'm going to solve for x. So I'm going to add 12 to both sides. That's 5x equals 18. Divide by 5, and you get x equals 18/5, or 3.6. For this one, I have 2 to the x plus 2, and I'm going to write 8 in terms of 2's. 8 is 2 cubed times 3x minus 4. If I'm raising a power to a power, I multiply my exponents. So I have 2 to the x plus 2 equals 2 to the 3 times 3 is 9x. 3 times -4 is -12. Bases are the same, so I can drop my bases and just focus on those exponents. So I have x plus 2 equals 9x minus 12. Subtract x from both sides, add 12 to both sides. So let's see, I got 14 equals 8x. Divide both sides by 8, so I get x equals 1.75. Number 27, write each equation in logarithmic form. So this is going to be a log base 10 of 1,000 equals 3. A log base 10 is just a regular logarithm though. So it's log of 1,000 equals 3. So my base for the exponential function is the same as the base for the log. Logarithm is an exponent, so it should always equal the exponent. And then 29 is just going in the opposite direction, so base for my logarithm, same thing as the base for my exponential function. Logarithm is an exponent, so 2 is my exponent, equals 9, which makes sense, since 3 squared equals 9. And for log of 1,000 equals 3, if there is no base, it's like having a base 10, so that's 10 cubed equals 1,000. To solve the logarithmic equation, so for this first scenario, I have log equals number, which means I'm going to change to exponential form. So 4 to the third power equals x minus 5. 4 cubed is 64 equals x minus 5, so x equals 69. And then for the other one, I have log equals log, even though they're natural logs. But if you have log equals log, you can go ahead and drop your logs and focus on what's inside the logarithm. So 3x plus 1 equals x plus 11. Subtract x from both sides, subtract 1 from both sides, you get 2x equals 10. So x equals 5. Exponential equations, I'm going to go ahead and take the natural log of both sides. So natural log of e to the x plus 2 equals natural log of 10. Natural log and e cancel itself out because it's the same base. So I have x plus 2 equals natural log of 10. Subtract 2 from both sides. You get x equals natural log of 10 minus 2. And if I plug that into the calculator, I get 0.3026. For the next one, I need to start by isolating this exponential function. So I'm going to subtract 1 from both sides. So that's 4 times 2 to the x equals 24. Divide by 4, 2 to the x equals 6. I'm going to go ahead and take the natural log of both sides. Natural log and 2 do not cancel out, but I can bring down that exponent. So I have x natural log of 2 equals natural log of 6. Divide by natural log of 2. Plug it into the calculator, you get 2.5850. All right, for expanding, expanding using the properties of logs means that I'm going to have each term in its own log. So I'm going to start by counting the terms in my parentheses. I have 1, 2, 3, 4 terms, which means I'm going to have 4 logarithms. So I have log, 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 log. So the first one is log of 3. For the x squared, any exponents is going to go in the front. So it's 2 log of x, y, and then 5 log of z. Anything that you're multiplying by, you're going to add in between your logarithms. And anything that you are dividing by, which in this case was the z to the 5th, you are going to subtract. And that is your expanded form. 36, you are condensing, so any numbers in the front get brought up as exponents, and anything you are dividing by gets put underneath, everything else is getting multiplied. So I have x cubed times y to the 4th divided by z plus 1 to the 5th. And there is your condensed form. All right, 37. Find the amount of time it will take for an investment of $2,000 to double at a rate of 6% if interest is compounded continuously. So we have a formula for continuously compounded interest, that is PERT. So A equals P e to the RT. And since I want it to double, my final amount is 4,000 equals 2,000 e to the RT. I'm going to divide both sides by 2,000, so I get 2 equals e to the 0.06t. Natural log of both sides. Natural log and e cancel, so I have natural log of 2 equals 0.06t. Divide by 0.06, and t is about 11.55 years. All right, systems of equations. Now, I would recommend that you use a calculator for these, using that RREF. So in the calculator, you're going to hit second, x to the -1, move over to math, and scroll down until you see RREF. So you're going to do RREF of this matrix, which is going to be 4, 5, 13, 3, 1, and -4, and then hit enter, and your answer is -3, 5. Once you hit enter, the calculator is going to spit this out. Oh, that's +5. And this right here is your ordered pair. 39, I'm going to do the same thing, except you have a bigger matrix. So RREF of 4, -1, 3, 6, -8, 3, -5, -6, 5, -4, 0, -9, and the calculator gives you the answer 360. So there is your ordered triple. For the word problems, you still have to set up the system by hand, but I would recommend putting it in the calculator to get your final solution. So a pharmacist needs 100 gallons of 50% alcohol solution. She has available 30% solution and an 80% solution. How much of each should she use? So I'm going to let X be the amount of the 30% solution and Y be the amount of the 80% solution. So the total amount of solution I need is 100 gallons. So I have X plus Y equals 100. And then for my X is the 30% solution. So 0.3X plus 0.8Y should create a 50% solution, but your 50% solution is of 100 gallons. So again, X represents the amount. So if I look at my second equation, what I'm doing is I have percent times amount plus percent times amount equals percent times amount. If I look at my first equation, I have amount plus amount equals amount. So it has to stay consistent throughout your system. So there's your system. So in the calculator, we can do the RREF again. So RREF, and my matrix is 1, 1, 100, 0.3, 0.8, and 0.5 of 100 is 50. I can take that and plug it in, and it ends up being 60 gallons of the 30%. So X ends up being 60, and 40 gallons of the 80%. So Y ends up being 40. Uh, 41 is also a mixture type of problem. So a butcher has some hamburger that is 80% lean and some that is 88% lean. He wishes to make 800 pounds of burger mix that is 83% lean. How much of each type should he use? So he needs 800 pounds. So X plus Y equals 800. So again, X is the amount of 80% lean, and y is the amount of 88% lean, so I have amount plus amount equals amount. Now I'm going to start to look at the percents. So 0.8 times x plus 0.88 times y equals 0.83, because that's what he wants the mixture to be, of 800. All right, in the calculator, RREF, 800, 0.8, 0.88, and 0.83 times 800 is 664. So I take that and plug it into my calculator, and it ends up being 500 pounds of 80% and 300 pounds of the 88% lean. Number 42, tickets to the school play cost $4.50 for adults and $3 for students. One night, 325 tickets were sold and $1,140 was collected. How many of each type of ticket were sold? So I'm going to let x be the number of adults, y be the number of students. So x plus y equals 325. Now I'm going to talk about the dollar amount. So it's $4.50 per adult plus $3 per student, and they brought in 1,140. So again, RREF is the best way to do this. I can take that and plug it into the calculator, and I end up having 110 adult tickets and 215 student tickets. And there is your system solved. All right, partial fraction decomposition. Okay, so I need to start by factoring my denominator. So that gives me x plus 5, just kidding, x plus 6, and x minus 3. So I'm going to separate this into two fractions. I have a over x plus 6 plus b over x minus 3. And to add these two fractions together, I would have to take a and multiply it by x minus 3. So I would take this first fraction, multiply it by x minus 3, and my second fraction, I would have to multiply by x plus 6. So b times x plus 6. And that should equal my original numerator, which is 8x minus 42. So I'm going to distribute the a and the b. So I have ax minus 3a plus bx plus 6b. And now I'm going to start to look at my like terms. So I'm going to look at my x's. So I have ax and bx should equal 8x. So a plus b should equal 8. And then negative 3a plus 6b should be my constant. So negative 3a plus 6b should equal negative 42. And again, you can use a calculator to solve for a and b. You can use the reduced row echelon form, and you end up with a equals 10 and b equals negative 2. So your final answer would be 10 over x plus 6 minus 2 over x minus 3. So just putting that a and the b back. Same thing for 44. I'm going to factor this. This is x plus 3, x minus 2. So I'm going to write this as a over x plus 3 plus b over x minus 2. My first fraction, I would have to multiply by x minus 2. So I have a times x minus 2 plus b times x plus 3, and that equals 5, my original numerator. So let's go ahead and distribute. Ax minus 2a plus bx plus 3b equals 5. So let's look at like terms, my x's. So a plus b should equal 0, because I don't actually have any x's. And negative 2a plus 3b should equal 5. Use my calculator to solve for a and b, and I get a equals -1, b equals 1. So we can set up the fractions. So I have -1 over x plus 3 plus 1 over x minus 2. All right. 45. Find the maximum and minimum value of the objective function and where they occur, subject to the indicated constraints. So I have my objective function and I have my constraints. It is already graphed for you, so you can go ahead and make a table. Vertices, objective, and value. So my vertices, I have one at 0, 2, 0, 0, 2, 1, and 1, 0. So I'm going to take that and plug it into my objective function. So I have 3 times x plus 2 times y plus 4, and that gives me 8. 3 times x plus 2 times y plus 4 gives me 4. 3 times x plus 2 times y plus 4 is 12. 3 times x plus 2 times y plus 4 is 7. So my max is 12, and that occurs at 2, 1. And the min is 4, which occurs at 0, 0. 46, you can plug right into the calculator, and your answer ends up being -32, -12, -14, -10, -12, -10. To put a matrix on the calculator, it's alpha zoom. You can do the same thing for number 47 because you're multiplying those two matrices. So once you do multiply them in the calculator, let's see, let me check the dimensions first. So I have a 2 by 2, that's definitely a 2 by 3. So 2 by 3 times a 3 by 3. Those two match, so we're good to go. So my answer is going to be a 2 by 3. So that gives me 99, 12, 25, -64, 44, -6. And there you go. Plug it in the calculator. All right, almost done. Conic sections. So find the equation of a parabola with the given characteristics. So my vertex is at -3, 6. My focus is at -3, 4. So I'm going to go ahead and sketch this out. -3, 6 would be somewhere over here. -3, 4 would be over here. So your parabola always opens towards the focus. So in this case, my parabola is opening down. I need to figure out what P is. P is the distance from my vertex to my focus. So I'm going from 6 to 4, which is 2 units. And since my parabola is opening down, I need to make P negative. Since my parabola is opening down, I'm using this equation. So x minus h squared equals 4p y minus k. So my hk come from my vertex. So I have x minus -3 equals 4p y minus k. And then 4 times -2 is -8. So x plus 3 squared equals -8 y minus 6. And there's your equation for the parabola. 49, I'm giving you the vertex and the directrix. So let's sketch this out. Let's see, 5, 7 would be somewhere over here. Just eyeballing it. Directrix is y equals 3. So it's a horizontal line. So my distance from a y of 7 to a y of 3 is 4 units, so P is 4. This parabola is opening up because if my directrix is underneath my vertex, then that means my focus is above the vertex, and it always opens towards the focus. So again, I'm going to use that same formula I used for the last one, which is x minus h squared equals 4p y minus k. So my h is 5, so x minus 5 squared equals 4p, 4 times 4 is 16, y minus k, y minus 7. And there's your equation for that parabola. All right, number 50. I believe there is a typo for number 50 and that this should be a -5. Otherwise, I don't think it makes any sense. Okay, so find the standard equation of the ellipse with the given characteristics. So I have vertices at +1, -5, 1, 13, and my minor axis length is 10. Okay. So let's find the distance between my vertices. So -5 to 13 is 18. Cut that in half. So A is 9. B is half the length of the minor axis, so B is going to be 5. Now, if I look at my vertices, it's my y coordinates are different, so that means I have a vertical major axis, which means the bigger number goes underneath the y. And then I still need to find my center. So my center is going to be 9 units away from each of my vertices, so that puts me at 1, 4. All right, so I have x minus 1 squared plus y minus 4 squared equals 1. Since I have a vertical major axis, bigger number goes underneath the y. So 9 squared is 81, b squared is 25. And there's your equation of that ellipse. All right, graphing. So find all the important parts of the ellipse and then sketch the graph. So bigger number is underneath the y, which means I have a vertical major axis. My center is at -3, 1. A is 7, B is 5, because I'm taking the square roots of these two numbers. So, since I have a vertical major axis, that means my x-coordinates of my vertices and my foci are all going to be the same. So I'm going to go ahead and write that part down. So for my vertices, I'm going to use A. So my A is 7, so I'm going to take 1 plus 7, which is 8, 1 minus 7, which is -6. My major axis length is the distance between my vertices, or it's also 2 times A, which is 14 units. And my minor axis is 2 times B, which is 10 units. Let's go ahead and start graphing. So -3, 1, there's my center. Going up and down 7, that puts me at -3, 8, and -3, -6. And then left and right 5 units. And I can go ahead and sketch my ellipse. Make sure you make it nice and curvy so it looks like an egg. That was beautiful. And the last thing I need are the foci. So there's a formula for the foci. It's c squared equals a squared minus b squared. So I have 49 minus 25. So c squared equals 24, square root. So c equals 4.9. So again, I'm going to take the y coordinate of my center and I'm going to add 4.9 to it. So that's 5.9. And subtract 4.9. Let's see, what's 1 minus 4.9? -3.9? Yep. Okie dokie. So let's graph it. There's one of my foci. And here's the other one. And there is the graph of your ellipse. Hyperbolas. So for this one, my center is at 0, 0. And I don't actually have a spot to write the center, so I'm going to write it myself. Now this direction is going up and down because my y is first. And for my vertices, I'm going to use A, but with hyperbolas, A is the first number, B is the second one. So A is 4 and B is 5. So since it is opening up and down, my y coordinates are going to change. My x coordinates are going to stay the same. So I'm going to go up and down 4 units for my vertices. That puts me at positive 4 and negative 4. Transverse axis length is going to be 2 times A, or the distance between my vertices, so 8 units, and conjugate axis length is 2 times B, or 10 units. All right. Okay, so my center is at 0, 0. Here's my center. Vertices, positive 4, negative 4, and I'm going to go to the left and to the right 5 units to create my rectangle. And the rectangle is going to help us with the asymptotes. So I'm going to draw my rectangle around these points. And through each corner of my rectangle, I'm going to draw the asymptote. And the asymptote will help us figure out how wide or how narrow to make each of my hyperbolas. Okie dokie. So now that I have my asymptotes, I can go ahead and sketch my hyperbola, extending towards the asymptotes, but not actually touching or crossing. Look at that beautiful graph. And last but not least, I need my foci. Oh, I didn't even write the equation for the asymptote. So the equation for the asymptote is going to be y equals plus or minus, and I'm going to look at the rise over run, so I went up 4 over 5. So plus or minus 4/5 x. Okay, for the foci, I have c squared equals a squared plus b squared, so that is 16 plus 25, which is 41. Square root. So I get c equals 6.4. So I have positive 6.4 and negative 6.4. So there's one foci. Here is the other. All right, so that covers every problem on your final exam review. Hopefully this video helps you get prepared. Good luck studying.